So it is the concept of mutual information. Mutual information. So let us see that mutual information concept. So in this, the mutual information, the information which is same as self-information. Same as the self-information. You know, the self-information is information which is the measure of information, which is the measure of information. So that is I of I is equal to log 1 by P of I. So that is the self-information depends on the probability of event occurs. Probability of event occurs. So now okay. So it is the mutual information. So it is defined as the information of the channel transfer noise and other transmission impairments alter the source information. Okay, it is defined as measure of information transfer. Nothing but the mutual information is it is a measure of information transfer. So whereas in the self-information, it is the measure of information only. It is the measure of information transfer. It is the mutual information. Mutual information is defined as the measure of information transfer. So the measure of information is a self-information. The measure of information transfer is a mutual information. So the noise contaminates information. Is it not? So the contamination means impairments are added to the source information, then the terror occurs. So in this, let us in the mutual information, if P of xi is the input probability and I is integer value, you know, P of xi is the input probability and I is integer value, and P of yj is the output probability for j is integer value. Okay. Now P of x comma y is the joint probability for I and j are integer values. Is the probability of that is the probability of yj is received. Yj is received when the probability of xi is transmitted. So yj is received when the probability of xi is received. Xi is transmitted. Okay. So the joint probability means yj is received when the probability of xi is received. xi is transmitted. Now P of P of yj by xi is the conditional probability that I and j are integer values. The when the probability of yj is received, when the probability xi was transmitted, So please identify the difference between joint probability and the conditional probability. Where the joint probability is yj is received when xi is transmitted. And the conditional probability is yj is received when xi was transmitted. That is the small difference between conditional probability and joint probability. Okay. Now that mutual information I of xi comma yj, I of xi comma yj. Now the mutual information is I of xi comma yj. Okay. Whereas in the self-information I of I only, no, the mutual information is I of xi comma yj is equal to log P of yj by xi by P of yj. P of yj by xi by P of yj. The units of mutual information is the same as the self-information, that is the bits. So the difference between mutual information and self-information is the measure of information only, whereas mutual information is the measure of information transferred. Measure of information transfer. How much information is transferred through a channel? That is the mutual information. Whereas it is also defined as I of x comma y. The mutual information is defined as I of x comma y. That is called log p of yj by xi by p of yj, units of the bits. So here it is, see this channel diagram, it is the channel diagram, xi and x1, x2 are the two inputs, x1, x2 are the two inputs, y1, y2, y3 are the two outputs. So the probability of uh, p of y1 by x1, p of y1 by x1, what it means? The probability of p of y1 by x1, p of y1 by x1 is the conditional probability. The conditional probability says yj is received when xi was transmitted. Xi was transmitted. That is p of yj by xi. This is p of y1 by x1 is the conditional probability, and p of y2 by x1 is the conditional probability. P of y3 by x1 is the conditional probability. Like p of y1 by x2 is the conditional probability. P of y2 by x2 is the conditional probability. P of y3 by x3 is the conditional probability. Probability of event on the path. So the P of y1 by x1, P of y2 by x1, so on. So this is like an example of a channel matrix, channel diagram. So the channel diagram, x1 is the inputs, y is the output, P of yj y by x is the conditional probability here. So now, if I of x comma y is equal to log p of yj by xi by p of yj. So then, if the channel is ideal, that is the channel is noiseless. The channel is noiseless. So that's why channel is noiseless means p of xi is equal to p of yj. Is it not? The channel is noiseless. There is no noise in the channel. Input is good output. Input is good output. Input is P of xi, output is P of yj. So that is, if the channel is noiseless, P of x1 is equal to P of y1. So that means, what is the probability P of yj by xi? There should be 1, because both are equal, no? So then the probability P of yj by xi is equal to 1. So P of yj by xi is equal to 1 means I of x comma y is equal to log 1 by P of yj. Is it not? Log 1 by P of yj. That is I of x comma y for lossless channel, for noiseless channel, for noiseless channel or ideal channel. For noiseless channel or ideal channel, I of x comma y is equal to log 1 by P of yj. Log 1 by P of yj. So what is log 1 by P of yj? Nothing but it is the self-information. Nothing but it is the self-information. So for the ideal channel, mutual information is equal to self-information. For ideal channel, mutual information is equal to self-information. So then the channel is ideal when the mutual information is self-information. If the channel is full of noise, what happens? It is P of xi not equal to P of yj. P of xi not equal to P of yj. In that case, I of x comma y is equal to log P of yj by xi by P of yj. So then it is not equal to 1. P of yj by xi is not equal to 1 for noisy channel. For noisy channel. For noiseless channel, the P of yj by xi is equal to 1. That's why for noiseless channel, the condition is self-information is equal to mutual information. Self-information is equal to mutual information. Then the properties of mutual information is there. Properties of mutual information is there. The mutual information of the please note on the properties of mutual information. Mutual information is a non-negative quantity. Mutual information is non-negative quantity. That is, I of x comma y greater than or equal to 0. So always the mutual information non-negative quantity means always it is the positive quantity. Mutual information is non-negative quantity. So it's nothing but it is a positive quantity. That is I of x comma y greater than 0. Greater than 0. 0 onward start. Now the mutual information is symmetry. Mutual information is symmetry. What is the symmetry? I have x comma y is equal to I have y comma x. I have x comma y is equal to I have y comma x. That is symmetry property. I have x comma y is equal to I have y comma x. And third property is mutual information is I have x comma y is equal to h of y minus h of y by x. Mutual information I have x comma y is equal to h of y minus h of y by x. What is h of y? Entropy of the output. H of y by x is a conditional entropy. Conditional entropy. H stands for the entropy, I stands for the mutual information. Okay. The mutual information is equal to I have x comma y is equal to h of y minus h of y by x. And mutual information I have x comma y is equal to h of x minus h of x comma x by y. So students, please be identify the notation. So I have x comma y is equal to h of y minus h of y by x. Whereas I have x comma y is equal to h of x minus h of x by y. So what is y by x and x by y? Y by x means y is an output, x is an input. Okay. Now h of x by y means x is an output, y is an input. Now the reverse. The another side can give an input. This side can take an output. Likewise, you can say that there is I have x comma y is equal to h of x minus h of x by y, whereas h of y is equal h of y minus h of y by x. So there are the two identical properties are there. Mutual information h of I have x comma y is equal to h of y minus h of y by x. Like the mutual information is equal to I have x comma y is equal to h of y plus h of x minus h of x comma y. X comma y, what is x comma y? X comma y is the joint entropy. Joint entropy. So here there are four types of entropies are there. One entropy is h of x, that is input entropy. Input entropy. X stands for the input of the channel. That's why h of x is equal to input entropy. That is sigma p of xi log 1 by p of xi. That is bits per symbol is the units of the entropy. And h of y is output entropy. Output entropy. How can it is calculated? Sigma p of y j log 1 by p of yj, bits per symbol. So then h of y by x. H of y by x. What is h of y by x? The conditional entropy. Conditional entropy. That is equal to x and y are involved here. That is two variables are involved. Where in the previous one, h of x and h of y, only the one variable involved. Where it is x and it is y. Now it is h of y by x is the two variables are involved. Then entropy is equal to sigma I, sigma j. Sigma I, sigma j. I stands for the input, j stands for the output. Sigma I, sigma j. P of x comma y log 1 by p of yj by xi. P of yj by xi. Okay. So that is h of y by x. Now, like h of x by y is sigma I, sigma j, p of x comma y log 1 by p of x by y now. Log 1 by p of x by y. So students, please we identify these third property and fourth property be the same, but one side input is given, x side input is given, y side output is taken. That is y h of y minus h of y by x. If suppose y side input is given, x side output is taken, then h of x minus h of x by y. That is the condition. Okay, now, and fifth property is mutual information is I of x comma y is equal to h of y plus h of x minus of h of x comma y. So what is h of x comma y? That is the entropy of the joint probability. Entropy of the joint probability. That is equal to sigma I, sigma j, p of x comma y log 1 by p of x comma y. That is the conditions. Students, the mutual information is the information. It is defined as it is the measure of information transferred. It is the measure of information transferred. That is equal to I of x comma y. You can denote mutual information I of x comma y. So that is equal to log p of yj by xi by P of Yj. Bits is the units. So the P of Yj by Xi is equal to 1 when the channel is ideal channel. That means noiseless channel. The channel is noiseless channel. So that is the condition. So please be note down the properties of mutual information. The mutual information is non-negative quantity. That means it is always a positive quantity. I of x comma y greater than equal to 0. Then the mutual information is symmetry. That is I of x comma y is equal to I of y comma x, and mutual information is equal to I of x comma y is equal to h of y minus h of y by x, and mutual information is equal to I of x comma y is equal to h of x minus h of x by y. Mutual information I of x comma y is equal to h of y plus h of x minus h of y by x, h of x comma y. Okay, so that is the properties of mutual information. Properties of mutual information. So let us see that next there is a problem regarding the mutual information. So if suppose note on the problem, shown in the figure, find out the mutual information of binary symmetric channel. Binary symmetric channel. Okay. So in that problem, it will say show that the mutual information of binary symmetric channel is the mutual information of binary symmetric channel is I of x comma y. I of x comma y is equal to h of y plus p log p plus 1 minus p log 1 minus p. When p of x is equal, p of x1 is equal to alpha and p of x2 is equal to 1 minus alpha. This is the derive that can prove that I of x comma y is equal to h of y plus p log p plus 1 minus p log 1 minus p when p of x1 is equal to alpha and p of x2 is equal to 1 minus alpha. Okay. The mutual information of binary symmetric channel. Okay. I have x comma y. You can show that is h of y plus p log p plus 1 minus p log 1 minus p. Okay. So now it is a problem. x1, x2, x1, x2, y1, y2, x1 is alpha, x2 is 1 minus alpha. x1 is alpha, x2 is 1 minus alpha. Now you know that p of y output is equal to p of x into p of y by x. You know this formula. P of y is equal to p of x into p of y by x. Okay, now p of y by x is equal to what is the channel matrix for this binary symmetric channel? 1 minus p, p, 1 minus p, 1 minus p, 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 1 minus p. So that is 1 minus p, 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 1 minus p. This is p of y by x. That is channel matrix. Now p of y is equal to p of x into channel matrix. What is the p of x? P of x value alpha 1 minus alpha. Now we can multiply alpha and 1 minus alpha with 1 minus p, 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 1 minus p. So what is this? P of y1 is equal to 1 minus p into x1 plus p into x2. That is called 1 minus p into alpha plus p into 1 minus alpha. So simply in place of x, x1 alpha and 1 minus alpha is two inputs. P of x1 is equal to alpha, P of x2 is equal to 1 minus alpha. So that's why P of y1 is equal to 1 minus p into alpha plus p into 1 minus alpha. Is it not? Simply matrix multiplication is 1 minus p into alpha plus p into 1 minus alpha. P into 1 minus alpha. Like y2 is equal to what is y2? P into alpha plus 1 minus p into 1 minus alpha. P into alpha plus 1 minus p into 1 minus alpha. So now P of y1, y2 are known. P of y1, y2 are known. Then find out the P of x comma y. P of x comma y. So P of x comma y is, how can you find out the P of x comma y? P of x comma y is the joint probability. joint probability. What is the joint probability? Yj is received when xi is transmitted. Yj is received when xi is transmitted. So now this is P of x comma y is equal to P of x in the diagonal form. P of y by x is the channel matrix. P of x in the diagonal form. P of y by x is the channel matrix. Now P of x, the values of alpha and 1 minus alpha, no? Alpha and 1 minus alpha in the form of diagonal, 0, 0 or another. Now 1 minus p, 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 1 minus p. It is alpha, 0, 0, 1 minus alpha. 1 minus p, 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 1 minus p. This is P of x comma y. So now simply P of x comma y, there are 4 elements. 4 elements. What are the elements? Alpha into 1 minus p, alpha into 1 minus p, and this is alpha p, this is 1 minus alpha into p, this is 1 minus alpha, 1 minus p, 1 minus alpha, 1 minus p. These are the, that is P of x comma y is equal to P of x1 y1, P of x2 y2, P of x2 y1, P of x2 y2. So this is the channel of joint probability, channel matrix of joint probability. Now we can simply matrix multiply, that is alpha into 1 minus p, alpha into 1 minus p, and alpha p, and p into 1 minus alpha, 1 minus alpha into 1 minus p. So simply uh, find out the I of x comma y. What the I of x comma y? So you can use one of the property from the I of x comma y. I of x comma y is the mutual information. No? From that mutual information, you have the 4 properties. One of the properties is always a non-negative quantity. Second property is symmetric property, that is I of x comma y is equal to I of y comma x. And third property is I of x comma y is equal to h of y minus h of y by x. H of y minus h of y by x. You know the h of y value. H of y is equal to sigma p of yj log 1 by p of yj. So that is output entropy. That is output entropy. H of y by x is equal to sigma I sigma j. H of y is equal to y by x is equal to sigma I sigma j. P of xi yj log 1 by p of yj by xi. So that is you can simplify this h of y by x. So how can you simplify? So in this p of x1 y1 log 1 by p of y1 by x1 plus p of x1 y2 log 1 by p of y2 by x1 plus p of x2 y1 log 1 by p of y1 by x2 plus p of x2 y2 log 1 by p of y2 x2. So this is the equation sigma I sigma j p of xi comma yj log 1 by p of yj by xi. For that p of xi comma yj have the 4 elements. What are the elements? x1 y1, x1 y2, x2 y1, x2 y2. For the all 4 elements can add the summation. So that is in expand this summations can know that p of xi comma yj p of x1 y1 log 1 by p of y1 by x1. So because of it is p of x1 y1, then the conditional probability is y1 by x1. So it is plus p of x1 y2, no? So that is log 1 by p of y2 by x1. That conditional probability is y2 by x1 plus x2 y1, x2 y1. Then log 1 by p of y1 by x2, conditional probability, plus x2 y2, log 1 by p of y2 by x2. So this is the value. So the p of x1 y1, the value is alpha minus alpha log 1 by p of what is the p of y1 by x1? Already here you can calculate these values. Alpha into 1 minus p alpha p, that is This is P of x1 y1, P of x1 y2, P of x2 y1, P of x2 y2. So substitute in this h of y by x, in the h of y by x, that is called alpha minus alpha p log 1 by 1 minus p plus alpha p log 1 by p plus p minus alpha p log 1 by p plus 1 minus alpha minus p plus alpha p log 1 by 1 minus p. You can substitute the values in the uh, uh, x1 y1. This is the joint uh, probability. Y1 by x1, this is the conditional probability. So y1 by x1 already we calculated this. Y1 by x1 is, this is the y1 by x1, this is y2 by x1, this is y1 by x2, this is y2 by x2. So this is uh, from the channel matrix. From the channel matrix, you can substitute the values of y1 by x1, y2 by x1, y1 by x2, y2 by x2. So joint probability values are calculated, and it is the conditional probability values are channel matrix in channel matrix terms. So now you can simplify this. You can simplify this. Minus alpha log 1 minus p plus alpha log 1 minus p plus alpha p log p minus p log p plus alpha p log p minus log 1 minus p plus p log 1 minus p plus alpha log 1 minus p minus alpha p log 1 minus p. So after simplifying this equation, can retains p log p minus log 1 minus p plus p log 1 minus p. So now h of y by x value, that is h of y by x value. So p log p minus alpha p log 1 minus p. P log p minus alpha p log 1 minus p. So now I of x comma y is equal to, the one of property, that is h of y minus h of y by x. H of y minus h of y by x. So therefore, I of x comma y is equal to h of y plus, this is minus now, minus into minus now, the plus, because h of y minus h of y by x now, minus into minus plus, that's why h of y plus p log p plus 1 minus p log 1 minus p. Hence proved for I of x comma y is equal to h of y plus p log p plus 1 minus p log 1 minus p. So this is the mutual information of binary symmetric channel when input is alpha and 1 minus alpha. Input is alpha and 1 minus alpha. So if the h of y value is output entropy, so if the output values are known, then calculate the output entropy. For the same problem, some statistical values are given here. That is, alpha is 0.5, p is equal to 0.5. P is equal to 0.1. Alpha is equal to 0.5 and p is equal to 0.1. Alpha is input values. Input is p of x1, p of x2 now. P of x1 is equal to alpha, p of x2 is equal to 1 minus alpha. That is, 0.5 is alpha, 1 minus 0.5 is again now 0.5. That is, p of x1, x2 is equal to 0.5, and probability is given. Probability is given as p is equal to 0.1 now. What is 1 minus p? 0.9. P is equal to 0.1, then 1 minus p is 0.9. Now for the values are given, what is the mutual information? The mutual information I of x comma y is equal to h of y plus p log p plus 1 minus p log 1 minus p. So then substituting this value, h of y is equal to 1, h of y is equal to 1, 1 minus p is 0.1 log 0.1 plus 1 minus p is 0.9 log 0.9. So after substituting the statistical values in this equation, then I of x comma y, the mutual information is equal to 1 minus 0.45. 1 minus 0.45, that is equal to 0.534. 0.534. So when it is, the mutual information is equal to 0.534 when alpha is equal to 0.5, p is equal to 0.1. Okay. If suppose alpha is equal to 0.5, p is equal to 0.5, What is the mutual information? Let us calculate. What is the mutual information? Let us calculate. That is called I of x comma y is equal to h of y plus p log p plus 1 minus p log 1 minus p. P log p plus 1 minus p log 1 minus p. So if suppose h of y is equal to 1, so p log p plus 1 minus p log 1 minus p should be the 1. That is 1 minus 1 should be 0. So the mutual information is 0 when probability is 0.5 and input also 0.5. So that is what is that condition says the probabilities are the same. The probabilities are the same and inputs are the same. Then the mutual information is 0. There is no mutual information. That is mutual information defined as information transfer. The information transfer is 0 when equal probability case. Information transfer is 0 when equal probability case. Equal probability case means p is equal to 0.5, 1 minus p also 0.5. So if the probability is not equal, then can calculate the mutual information. The above case, that is alpha is equal to 0.5, p is equal to 0.1, then that mutual information is equal to 0.534. So if alpha is equal to 0.5, p is equal to 0.5, that is the case of equal probability and the mutual information is 0. So what is the mutual information? Mutual information is the information transfer. The measure of information transfer is nothing but the mutual information. The measure of information transfer is nothing but the mutual information. Okay. Based on the mutual information, you're able to calculate the channel capacity. Based on the mutual information, you're able to calculate the channel capacity. So now the channel capacity is defined as the channel capacity of a discrete wave channel is defined as based on the mutual information of the channel, that is when the power spectral density function of input and output of the channel is maximum. The power spectral density of input and output the channel is maximum. So that is the channel capacity. That is channel capacity is there. The power spectral density is maximum case. That is the channel capacity, maximum channel capacity. So that depending upon the input and output power spectral density can measure the channel capacity. So that is one of the important parameter to know the channel capacity is mutual information. So now that C of S is channel capacity, C of S is equal to the maximum of P of Xi of I of X comma Y. Bits per symbol. Okay. So the channel capacity C of S is defined as the maximum of P of X, the channel input entropy, the maximum input entropy of I of X comma Y. Okay, that is I of X comma Y is mutual information. That is information transfer. So information transfer is the maximum when the input possibility is maximum. That is the definition of this CFS. CFS is equal to CFS is equal to the maximum channel capacity when the calculation of I of X comma Y for input possibility is maximum. Okay. If suppose there is 4 signals are transmitting through a channel. 4 signals are transmitting through a channel. For the 4 signals, individually calculate the power spectral density. For the 4, one of the signal power spectral density is maximum. One of the signal power spectral density is maximum. So that is the entire channel capacity. That is the entire channel capacity. Now the entire channel capacity is depends on mutual information and the maximum power spectral density of the signal. The maximum power spectral density of the signal. Suppose there are 4 signals are transmitting through a channel. Among them, one of the signal has the maximum power spectral density. That is the entire channel capacity. So that is nothing but CFS. CFS is equal to maximum of P of X for I of X comma Y. That is known as bits per symbol. CFS is bits per symbol. Now the channel capacity C is equal to small r into CFS. Small r is symbols rate, symbols per second, symbol rate. So CFS is bits per symbol. Now the C is equal to channel capacity is equal to small r into CFS is nothing but bits per second. Channel capacity C is equal to bits per second, where CFS is bits per symbol. That the symbol capacity of CFS, and C is small r into CFS. That is the channel capacity. So, now you have to know the some specific channels. Know the specific channels for them. Calculate the channel capacity. Channel capacity of specific channels. One of the channel is last stage channel. You know the last stage channel. What is the last stage channel? Last stage channel is the channel having one non-zero element in each column and remaining elements are zeros. One non-zero element in each column and remaining elements are zeros. So in the last stage channel, so conditional entropy h of by x by y is equal to 0. X by y is equal to 0. That means last stage channel, there is no loss in the channel, then x is equal to y. The x is equal to y means a transition entropy. Transition entropy is 0. Therefore, the mutual information I of x comma y is equal to h of x minus h of y by x. You know that mutual information one of the property I of x comma y is equal to h of x minus h of x by y. No? So now that is in that case h of x by y is equal to 0. Then I of x comma y is equal to h of x only. That is for last stage channel. So thus the mutual information transfer rate is equal to the input source entropy, and the noise information is lost in the transmission. Noise information lost in the transmission. That is C of S is equal to maximum of P of x, I of x comma y bits per symbol. Or the C of S is equal to h of x. The h of x is equal to the maximum for when the h of x is maximum. H of x is the entropy of the input. No, when it is maximum, for the equal probability case, both are the equal. Both the inputs are equal probability. Then that C of S is equal to log m base 2. M is the number of signals, number of levels, number of signals here. So log m base 2. Okay. So that is the last stage channel. Channel capacity C of S is equal to log m base 2. And the second channel is deterministic channel. What the deterministic channel? Deterministic channel is the channel which is the one non-zero element in each row and remaining elements are zeros. For the deterministic channel, h of y by x is equal to 0. Where the last stage channel, h of x by y is equal to 0, h of y by x is equal to 0. Now that h of y by x is equal to 0, you know the property I of x comma y is equal to h of y minus h of y by x. No, h of y by x is 0, I of x comma y is equal to h of y only. So that is the mutual information of deterministic channel is only h of y. That is C of S is equal to P of x maximum of P of y, f x comma y. That is log n base 2. N is in number of signals like m. So for deterministic channel and the last channel, so same as this. That is I of x comma y is equal to h of x by y is equal to 0 and h of y by x also 0. So that is log m or log n are the channel capacities of the deterministic channel and last stage channel. So already you calculated previous problem for the binary symmetric channel. So on the what is the noiseless channel? It obeys the properties of deterministic channel and also last stage channel. So that's why I have x by h of y by x is equal to 0, h of y by x also 0. That's why f x comma is equal to h of y minus h of y by x. That is h of y, that is log m base 2 or log n base 2. C of s is equal to log m base 2 or log n base 2. This is the noiseless channel. Whereas the binary symmetric channel, you know that one problem is done in this in this previous one. That is C of S is equal to H of I plus P log P plus 1 minus P log 1 minus P. So students, please remember this channel capacities of these four types of channels: determinate channel, last channel, and binary symmetric channel. Okay. So okay, please we go through the textbook once for the channel capacity and mutual information. Okay, next let's go for some problems regarding the mutual information and channel capacity. Thank you for listening. Thank you, one and all.